Hey everybody, jumping on for a short one tonight. So we are back in the Kerbalist. We've added yet another immersion mod, this time the probe control room. We've added a new rule as well, which is flight control of unmanned vehicles must occur through the probe control room. I can caveat, unless there are local Kerbals to fly it via local remote control. So in other words, if you're on a moon base, you can have a little unmanned probe that we can fly directly because there's Kerbals there to fly it directly. But otherwise, we have to fly it through the probe control room. So let's check that out. Tonight we're also going to do some programming with kOS, just a little bit. So let's jump into it. All right. So I'm not going to actually fly any missions, but the mission goal, we did the moon flyby last time. So the next mission is going to be set up a ScanSat satellite in lunar polar orbit, so we can start getting some biome data for future manned mission, and land an automated Alright, so these are both going to be programming challenges. So let's kind of get into that, and we'll get started on it tonight, testing stuff out, but that'll probably be the next session or two after this as well. So let's check out the probe control system kind of first. Okay, so we've got this new Probodyne Octo. Probodyne Octo has a bunch of experiments, which is good for us. Some pilot assist, which doesn't really matter for us. We can scan terrain. Okay. We're going to set the IVA to D, which we'll explain in a minute here. That's going to be sort of for testing. I think this thing has a reaction wheel. It does. Okay. So we don't have to do too much with this. That's kind of big. This might be a good starting one to use. All right. So sorry if I was too far away from the microphone before. I'm still getting kind of used to things. Don't really have any smaller engines yet. Okay, so TWR is 1.3. That means we have enough thrust to lift, basically. I think this will actually kind of serve as a good little test here. We're going to need some cameras as well, because that's how this is going to work. So we're going to add a booster cam. That kind of points down. And then let's see if we have a different option here. So moon cam that kind of just points out. I'm not sure the moon cam actually does anything in terms of what we need it to do. Yeah, so the moon cam is not a hull cam, which is what we actually need. Yeah. Okay. It's got 2 cameras. Got this guy, which has 50 electric charge. Probably need a little more electric than that. And now we have this nice battery bank. That's handy. And we have some solar panels, which I'm tempted to put on here just because we finally can, but honestly, we don't really need them. Not for testing like this. And the last thing we for sure need is the scriptable control system. Alright, so this is our little probe. We're going to call it, get some insect names, I think. Ladybug 1 was our first one. This is kind of a test vehicle, so let's just call it Grasshopper 1. Grasshopper can be our test line of unmanned vehicles. Okay, finally, we select the probe core, and we're going to pick the probe.kOS boot script. So this is something I have worked on a little bit since the last time I did any Kerbal spacecraft, so I'm going to walk through this. This code is all available on my GitHub. Well, I have to push some changes after this, but if you go to github.com/tsraveling, you can see I have a public Kerbalist repo where a lot of this stuff can be found. So basically, we've got 3 folders here. So we've got the boot folder, the episodes folder, and the lib folder. Episodes will have a numbered folder for each episode. So, you know, this episode is, I've forgotten what this episode is, honestly. Whatever this is showing up as is what it'll go up under. Then we have lib, which just has shared functions. So let's actually kind of go through these real quick. So the functions in core.kOS are download. Download will download a file from the mainframe. Download and run will download a file from the mainframe and then execute it. Notify pops up a HUD text. Add alarm if needed. Adds an alarm using Kerbal alarm clock. Basically, this is for so kOS seems to like it works in real time, but it doesn't work if you're under a super high warp. So this just creates an alarm in Kerbal alarm clock that lets you manually warp to that or switch to a different flight or whatever you want to. It doesn't do the warping automatically because I prefer to do that by myself. These are where we have the delays, and I'm kind of working on this right now. So call home checks for a connection to the Kerbal Space Center. It then checks for the delay time, and if that delay time is more than 30 seconds, it creates an alarm clock for it. So what this basically will do is it'll simulate the delay time all the way back to the Kerbal Space Center. So if we're on the moon, it'll just be a couple seconds to upload a file or do whatever we want. If we're on Duna, say, I can't remember exactly, but I think it's anywhere from 20 seconds to a few minutes, depending on where Duna is in relation to Kerbin. And that will, if it's further away, let alone like Joule or Elu or something, it'll put an alarm clock saying, switch back to the thing when the upload is completed. Call controller does the same thing except checks for a control connection. For instance, like a base or a ship. Basically, any manned Kerbal craft that has a sufficient antenna, it can do that instead. All right, so probe.ks does some simple stuff here. That's supposed to be like that. It first copies this core file into the local hard drive. Actually, I'm not sure why this is here. So I don't know if there's an option to end the, there you go, just say shutdown. This is some error handling. For some reason we're not able to get that boot file, then okay, I see. I think this is what this is. Basically, we only want to copy it if it does not exist. We might mess with that a little bit later, but that's fine. Run once, runs the core, so then now we have all this in here, and then we can use it for anything else. Okay, so check for commands. Local command file to command.ks. So what this will do is, oops. If I were to put something in here with, actually, I'm going to do like this. But I don't think it really matters. Whatever. So if I was to put it in here, grasshopper1.ks, then that would sort of copy that command from this folder. It will call for the nearest control node, like a Kerbal base or whatever. It'll download that. It'll wait the delay time to the nearest control node, and then it'll download and run that file. It'll delete the file off of the local, and it'll delete the file off of the let's see. It'll delete the file off the archive, and it'll delete the file off of the local as well. So basically what this lets us do is it lets us send a new command by preparing it in this file here, and then when it connects, it'll check for that, and if that file exists, it'll execute it. This is important for kind of far away stuff. And that's kind of for like temporary commands and stuff. So I have to still kind of figure a little bit how we're going to actually handle actually controlling stuff, and that's what tonight's about. So let's just kind of see how this all looks in action for right now. Save this. We set the EVA to DE. We're going to launch. Okay, here's a little probe. And here is the Kerbal Command Center. Alright, so this basically allows us to control the probe through this. And in this series, whenever we're flying an unmanned vessel that doesn't have a local pilot, like somebody in a nearby base or ship that can control sort of by hand, we're going to be controlling things from the Kerbal Command Center, which is this. So a lot of different stuff we can put on here. So remember we put those extra cameras on there. This is the staging camera looking down here. And then we're going to set this one up here to the to that outward facing camera like that. And up here we can say like an orbit or something. That looks kind of good. And then down here we can have stuff that's actually useful for flying it, which for us is going to be the attitude and of course kOS. So you can see here what happened, which is the Grasshopper 1 automation core came online. No new commands are found. Powering down, program aborted. So, let's see if I can use this at all. Interesting. So it's shutting down, which is not necessarily what we want. Okay, that's fine. That shutdown command at the end is actually shutting down this, which causes it to power off. This button here will reboot it, which is kind of good for us in the long run. However, it's not exactly what we want here. But let's kind of see how this looks in terms of flying this thing. So, I can turn on SAS, stability assist, and I can put a little bit of throttle on. And let's try this out. Go, we got liftoff. I can fly it from here, I believe. We're going to just fly it out and crash it into the ocean as our first test flight, more or less. You can see descent is here. See, we're out of fuel. And we are coming down into the ocean. Got alarm. Poof. There we go. There's that strange black ocean effect again as well. Kind of disturbing. I'm going to have to figure out what causes that at some point. Alright. But for now, we're going to call that a successful flight. And we're going back to the Space Center. I feel like it might be one of these. Don't really know. Yeah, okay. So, our next task is going to be kind of figuring out, okay, so how are we going to actually control this? So let's actually modify the boot script first of all. No new commands found. Settling in. So we're not going to shut down automatically. Regardless of what happens here. So, I think what we can do is we can sort of create custom boot. I think we can sort of have a custom script. So let's actually try this out. Let's try Grasshopper. kOS. I'm putting this in boot. And I'm going to say I'm going to copy Okay, let's see here. Include, acquire, nothing like that. Okay. So here's how we're going to do this. Okay, so that runs the base script. So we can do everything we can normally do with a probe, but now we can also do other stuff. Like we can use all of the files, all of the functions that we defined in here, for instance. So this is sort of like an ad hoc extension, is what we say here. And what I think I might like to do is just kind of test some stuff out right now. So let's say if we want to lock throttle to 1. Lock heading, no, steering to heading. I think 90-90. Stage. Wait 5. So wait 10. So you say wait until alt radar is more than 200. Let's put some logs into here as well. Print launching until our radar is more than 200. And let's actually also, so we're gonna check the docs on this. Northeast 10 degrees above the horizon. Okay. You know, let's actually go. Let's go south over the mountains. That should be kind of interesting. So here's what we're going to try to do, though. So we're going to say launching, throttle. We're going to say staging. And we're going to say print angling down. Print target alt reached. Slowing down. Yeah, so we're going to be shooting up at this point. So we can say, let's try this. Wait until, so lock steering to surface, let's see, retrograde? Surface retrograde. We're going to wait until here. Say lock throttle to 0. here's where things are going to get kind of interesting. So we're going to say, until landed, until ship landed. Nope. Until ship status equals landed. Or total max thrust equals 0. We're more or less just gonna try to land this thing by wire. Okay, so that's grasshopper.ks. Now we'll just see if it works. Now I'm tempted to switch this around a little bit, because we can actually load things directly. Let's just see how it goes. Okay, put this, and we're gonna switch to yes. You know what? I think I'm fine with this. We're gonna switch this up a little bit. Okay. Let's say we're gonna actually switch this around here. We're gonna assume probe was already on there, and we're gonna copy this directly. Let's see how that goes. Okay, so we're gonna stick with probe. kOS, which is no longer exiting. We're gonna launch. Okay. Okay, so you can see here we have no new commands found settling in. So what I can do now is I can say copy. I have to hit this to lock in the keyboard. Copy path 0 test grasshopper.ks to 1, let's say run.ks. Should put that on the, okay, there we go. Got the camera. There we go. Exciting. Okay, say, I think, bird to launch. Hopefully I didn't crash it by doing that. No, there we go. Actually have this on. The vessel view. Okay, here we go. Our altitude is up, going over 100, angling down. There's 200, target altitude reached, waiting for descent. We are in descent. And basically, yeah. Okay. Well, it's getting annoying typing that in every time, so let's actually let's actually add a new feature to our Kerbal script a little bit here. So revert to vehicle assembly, first of all. Let's add a thing here. So checks for commands. Let's add a new folder, autoload, in the top one. We're going to kind of do this exact same thing here. we could probably check just kind of check to see if we're close enough for this as well. But we can actually add something here, say and not exists 1. Unlike let's actually say auto file. So basically we want to say, is there an autoload file with the ship name? If that exists in the Kerbal Space Center but not locally, we're going to autoload the file. So we're just going to say download. We're going to assume autoloads are at the Kerbal Space Center. And we're going to say download auto file. Not going to delete anything. I'm going to say print loaded into local storage as. Let's try that actually. That's old PHP syntax. I don't know where that came from. Okay, so what we're basically saying here is there's a parameter local path. By default, it's file path. So if you don't include it, it'll just use the same. But if you do include it, you can set it to whatever you want to. That's what that means there. Okay, so column download auto file, and we're going to say start.ks. And we're just going to say instead run start.ks to begin. I'm tempted to have this attached to like an action group or something like that. It's kind of an interesting idea. So how can we actually do that? A dedicated launch action group. That's an interesting thing, this launch action group, but AG1, let's say. Here we go. Now we're talking. Okay. So we're gonna try something which might be a little unsafe. I'm not really sure how this works with kOS. But we're going to then run start.ks or trigger AG9 to begin on AG9 run start.ks. Okay. Okay. A lot of changes. Let's kind of see how it works. I think we have to save. I think we have to leave and come back into the Kerbal space to the VAB to load that new script. And of course, we need to also create that autoload folder, or we need to create the autoload file rather. So move this up here. Grasshopper.ks. We're gonna set this to grasshopper1.ks. And then we're gonna say print grasshopper1 starting launch script in 5. Let's say it's just 3. Okay, well, let's see if all this works. Okay, I can now set the boot file is probe. I guess I didn't need to set out of it or not. Okay. So if I am correct, then when I launch this, it should load the autoload script, but it shouldn't run it until I trigger the 9 action group on my vessel. So let's see how we're doing. Okay. So as always, we're going to set the cams. I do wish there was a way to sort of save your config for this. Something I might have to look into. That's fine. I'm going to put the flight information here and the Kerbal information here. So we have copied autoload grasshopper1 cast to local storage, run start a cast, or trigger AG9 to begin. All right, well, let's see if this worked. Does not seem to do anything. No, let's try this anyway. Go. We are launching. Okay, so one thing that's very obvious is that it is not at all changing towards retrograde. So let's revert. While that's loading, let's look at this. Run start.kOS or trigger AG9 to begin. Okay. I'm tempted to just run it anyway. Let's try this. Run start.kOS. And then on Grasshopper 1, let's say print name ready AG9 to begin. Wait until AG9. Okay, let's try that. I think if I reboot, oops, that's not gonna actually do it. So I'm gonna do a full launch reversion. Ah, yes. The boot only changes. This boot script only changes when you actually fully reload. So if I revert to vehicle assembly and then start from there, that should work, I think. Because the boot script gets copied in at launch. And so if you revert to launch, it'll just use whatever the boot script that was copied in when you first launched it. So you have to actually revert to the KSC to then load it. So now, I believe, there we go. Grasshopper I1 ready, AG9 to begin. Okay, let's see if this works. Let's do some cameras. Let's do attitude. Let's do flight landing here. And then let's hit the 9. Starting launch script in 3. There we go. Perfect. However, we know exactly what's going to happen at this point, which is the same thing that always happens. So we're going to revert launch. Meanwhile, going to mess with the autoload script here. Okay, so let's change this up a little bit. Let's say wait until we're above alt radar 30. Wait until alt radar is more than 100. We're in descent. Lock steering to surface retrograde. Let's find out what that means. Okay. So I still feel like surface retrograde is correct. Let's look at some of these guys. So this is a hair crazy dev, hoverslam.kOS. By the way, I have been learning a lot from a specific, yeah, I'm not sure I'm gonna find it today. There's a specific YouTuber that I've watched some videos of from like 10 years ago, so I'll try to specifically mention him last time. But let's see where we're at. Lock steering to surface retrograde. So that is actually how they work. Wait until vertical speed is less than 0. We are in descent. Lock steering to surface retrograde. Wait until alt radar is less than 100. Lock throttle to 1. That feels like the part that's not happening here. Maybe it's actually just not possible. I guess that's possible. I'm gonna do a test here rather than flying it from there. Just gonna fire. There's no sass on this thing. Yeah, this is the issue. So it just does not have any ability to control itself. It's too heavy. That makes sense. So what I'm going to do is a small reaction wheel. It's getting sillier looking all the time. Save. Launch. And let's try it again with this in place. All right, so once again, we are putting on the camera. So it doesn't really do much, but I guess we have it anyway. Okay. Got that nice early turn going. That's great. Alright. Interesting. That's kind of working. Not well enough. Oh. Haha. Look at that. Not the prettiest landing you ever see, but that I think is a success. That's pretty cool. Below 100 meters, burning. No new commands found. Settling in. May have forgot to put a landed. Should have had something there at the end to kind of just celebrate, but that's fine. That's pretty cool. Okay. What I should have done is lock the pilot throttle as well to 0 because if I had manually changed it before, then it would have shot up. All right. I think that's a success. Can we recover from over here? Yeah, there we go. Also, we have free IVA, which means I can actually walk around, kind of look at some of this stuff. Got solar arrays, quick save, quick load up there. That's kind of cool. Voice comm chatters, receiver. I will take it. Don't know is how to then recover. Maybe that's something we actually just do from the... Well, you can only recover on Kerbin, so I guess by definition you should be able to recover, right? That makes sense. Beautiful. Look at that. Alright, I think we're going to call that a success for tonight. And tomorrow, assuming we're on, we will maybe try to do some more advanced stuff with this. So, that was cool. Have a good night.